Continuing on with removing the greatest common factor, D is very similar to example C on the last slide. We need to look at what is common to those coefficients, 24 and 42. Well, we can take a 6 out of both of those. So 6 will form part of our greatest common factor. Both terms have x's and y's as variables, so then we need to look at what is the smallest exponent on x, what is the smallest exponent on y. Smallest exponent on x is negative 3, smallest exponent on y is negative 2, so our greatest common factor that we take out should be 6x to the negative 3, y to the negative 2. When we take that out, we divide it out. 24 divided by 6 gives us 4. Our x to the minus 3 that we took out cancels our x to the minus 3 that was given. Exponent on the y squared, we took out y to the minus 2. 2 subtract negative 2 will give us 4y to the 4th. Looking at our second term, we took a 6 out of 42, that leaves us with 7. Exponent on our x originally was 1. Remember that exponents of 1 are not generally written, so we have 1 subtract negative 3. 1 plus 3 gives us 7x to the 4th. Exponent on y, both y to the minus 2, they cancel each other out. And there we are factored. E, we step away from negative exponents, but we now look at fractional exponents. Nothing changes. We still look at the coefficients first. 1 as a coefficient on x to the 3 over 2. 4 as a coefficient on x to the 1/2. Nothing is common. We can't take out a coefficient. There's an x as a variable on both terms. Smallest exponent that we see is x to the 1/2. So that becomes our greatest common factor. Still works the same way, except now we have to do the subtracting with exponents. Not a big deal. We had x to the 3/2. We take x to the 1/2 out. 3/2 minus 1/2. 3 minus 1 gives us 2 over 2. Or just x to the 1, which I'm just going to write as x. Second term, we had no coefficient that we took out, so the 4 stays as is. We took out x to the 1/2 from x to the 1/2. They cancel each other out. All we have left is 4.